and welcome back to the Inside Java podcast, a podcast about everything Java brought to you directly from the team at Oracle that builds Java. My name is Chad Arimura, and today is episode 8, Project Loom. My guest is Ron Pressler. Ron, thanks for being on the show.
Hi, thanks for inviting me.
So I'm going to start with the most important question. How many cats reside in your house?
3.
And do you have a favorite cat?
I'm not supposed to say. My wife will get angry. Yeah.
Because I've seen countless videos of your Loom talks with a little kitty running across the background.
Let me try to see if I can record her purring.
Okay. And the name of this cat that was purring?
Schiff.
Schiff.
Long
Okay.
story.
Well, I didn't know I was going to have 2 guests today. Schiff, thanks for being on the show. Okay, shifting gears slightly. Tell us how you found yourself at Oracle in charge of Project Loom.
I think it started around 2015. At the time, I was working at my own startup, and one of the side projects I did there that later on became like one of our main projects was called Quasar. And Quasar attempted to add lightweight threads of fibers to Java as a library using various bytecode manipulation tricks. And I think it was 2015, Alexei Shiplev invited me to speak at JVMLS. I gave a talk there. I guess people liked it. And I think it was a year later, in 2016, I got a call from Brian Getz. I known him earlier from other conferences, but he asked if I wanted to come work on this at Oracle. And at the time, my company was still active. I said no. But a year later, in 2017, early 2017, the company was not doing so well. So I called Brian again and asked him if the offer is still open. He said yes, so the rest is history.
Well, recruiting is always the long game. We're glad to have you. So give us an overview of Project Loom then.
So Project Loom is about making it easier to write scalable concurrent applications. So applications that do many things at once, many different tasks, many different transactions at once. Scalable means that they do many of those at a high rate, and making it easier means that, I think it's best to put it this way. Today, developers have a dilemma between writing code that's harmonious with the design of the platform and writing code that's scalable. Concurrency in Java means threads. The entire platform is built around them. Not just the languages and libraries, but also the tooling like the debuggers and profiles, etc. But threads are very expensive. And if you want to write an application that does a million things at once, and you can't have a million threads. So people try to circumvent them in order to make better use of the hardware. But then they write code that's disharmonious with the platform. So they have to choose between wasting developer time and wasting their hardware. Either way, they spend money that they shouldn't. And Project Loom is about removing that dilemma to allow you to write very, very simple, straightforward code that performs as good as possible.
I've seen you talk about concurrency versus parallelism. I think it would help to just give a brief overview of the differences of the two and how those apply to Loom.
So the definitions I use come to serve a certain goal of explaining something. So for the purpose of discussing the things that we'd like to discuss, I would say that parallelism is the problem of how to solve a single task faster, so namely with a lower latency, by taking advantage of multiple processes. Concurrency is a different problem. It asks, how do we process a great many mostly separate tasks by scheduling them to a much smaller number of processing resources like processors. So in parallelism, you have one task and you want to make it faster. Concurrency, you have a great many tasks and you want to make the best use of the hardware in order to process them.
And Loom focuses a lot on concurrency as opposed to parallelism.
Exactly.
How does this apply to end users? Are you looking for feedback from end users? How can they get engaged with the project?
Yes, getting feedback would be great. The best feedback is to download the early access binaries, use them for something real or real-like, so namely various servers, microservices, etc., and let us know about the experience. And by experience, I mean how easy it was to use the API, what's missing there, and also performance, good, bad, what could be improved.
Mm-hmm, mm-hmm. And are there specific use cases? You mentioned microservices. Is there an area that makes sense for Loom today? If somebody says, I really want to kick the tires, like what are the types of use cases that you would suggest somebody has in order to go and test it out?
So I think that the canonical example of a good use case for Loom would be a server. Receiving, it could be a database server, it could be a web server of some sort, it could be a REST service, anything that gets many different requests over the network and processes them concurrently. So that would be the best use case. And Java is, of course, used a lot for this kind of application.
You talk about structured concurrency some as well. It seems to me, having tracked Project Loom now for a couple of years, the structured concurrency, your thoughts around that have been developing more as of late. So things like deadlines, invoke any, invoke all. It seems to me like those are recent additions to Project Loom. Is that true?
Yes, they're more recent, partly because structured concurrency as a famous concept, let's call it that, is also quite recent. The main benefit you get from Project Loom comes immediately by virtue of making threads lightweight. Some people think that if you just have more threads, then you'd have more of the problems associated with threads. But that's not the way it works. It's like saying that a smartphone is just a miniaturized mainframe, and so it has all the problems that mainframes have, but we only have more of them. So some of the problems maybe, but sometimes miniaturization itself changes the nature of how things are used. So when threads were few and expensive, we had to pool them, we had to manage them in very difficult ways, and that in itself introduced some problems. But if you can now spawn a new thread for every task you want to do and not think about it, that in itself makes many things much easier. You don't have to care about thread locals leaking from one task to another. You don't have to care about interrupting a thread in order to cancel some task but accidentally miss it and cancel the next one that runs after it. That alone is the main benefit. But because people will now create many more threads, we thought that it would make sense to add additional constructs that would make it easier for them to manage them. And we came across structured concurrency in a pair of blog posts by Nathaniel J. Smith. He didn't coin the terms, he just described it very well after having read about it. I think the person who coined it was Martin Sustrick. Those couple of blog posts, I think, were the rare case where I read something and immediately I thought, yeah, that's the right way to do it. Usually, technical blog posts say, I'm not easy to persuade, but these two blog posts were very persuasive and it was very easy to see this is the right way. And the other members of the team read it and thought the exact same thing. We started thinking about how to do it in Java, and the main problem with it, I think, was that it's new. It's not just new in Java, it's new in general, and people don't have too much experience with it. And when we add stuff to Java, we try to think, 20 years ahead. And we were scared to add a new kind of API or a whole new basic framework into the JDK that people don't yet know if it works well or not. So we thought that we might do something provisional, but then Alan Bateman saw that we can do almost everything we'd want out of structured concurrency just by making very small changes to existing constructs like execute a service, making that auto-closable, and that alone gives you like 95% of what you'd want from structured concurrency. And that in itself is something that is clearly a good idea. So it was a very small change. It's obviously a good idea, and it lets us at least experiment with structured concurrency without committing to it forever.
I remember when we were working on FN Flow, we had implemented the completable future API, which tended to get pretty nasty. The programming model I think, you and I had talked about this years ago. It's not a fun way to program, let's put it that way. And it's kind of like it leaves your head spinning a bit. Will Loom simplify some of that? Give you kind of some of that idea of structured concurrency, but in a much simpler programming model?
Absolutely, and I say that I don't think completable future is structured concurrency. So maybe I should say what structured concurrency is. But first of all the existing APIs like completable future will continue to work, and if you enjoy working with them, I think completable future has upwards of 70 methods or something like that. So it's hefty. But if you enjoy it, you're welcome to use it. It will continue running the exact same way. But if you don't enjoy it so much, and I don't most of the time, then you just need to use future.get. The whole of asynchronous programming, and completable future is an example of it, is doing stuff to avoid blocking the thread. So to avoid blocking future.get.
Right.
But because virtual threads are cheap, you don't need to avoid doing that anymore. So all the 70 methods there created to avoid calling get, you can just call get now.
Right.
But structured concurrencies is different. Structured concurrency is about, I guess it's related in some way, but structured concurrency is about managing the lifetime of threads. In general, the concept of structured, like structured programming, is about reflecting various properties of a running program in the structure of the code. Before structured programming, when we had GoTo, so the way the program jumped from one place to another in the code, and it was hard to look at the code. I started out programming in BASIC, right? So I was used to it. But you can't look at the code and see the control flow of the program. So structured programming is about the structure of the code, the textual structure of the code reflecting the behavior of the program. And the same is with structured concurrency. Unstructured concurrency is where you call some subroutine and it spawns a thread and returns. And you don't know anything about that thread's lifetime. It's out of your control. It decides when it wants to finish and die. You don't know anything about it. Structured concurrency means that you don't do that. When you create a thread, it begins and dies inside a single code block. So you can look at the code and see where the threads are born and where they die.
Right. I think we may have glossed over the developer interface to Project Loom a little bit. So I'm a developer. I want to start using Loom. Do you just implement the standard thread API and then offer a layer on top called virtual threads? And how is that interface for programmers?
Yeah, so it's easy to gloss over it because it's so small. There is nothing much to learn. You just write code as usual. If you want to create a thread manually, most people don't do that. But if you do, then there are several new factory methods on thread. But most people would use a new builder interface for thread that you can configure the thread to be either virtual or platform. So platform thread maps one-to-one to an OS thread. A virtual thread you can have millions of. So when you create the thread, you choose. Most people, however, just as today, they don't construct a new thread by hand. Rather, they use Java util concurrent executors. We've added a new kind of executor, which we call a new thread executor. And unlike most others, it's not a thread pool. Every time you submit a task to it, it will spawn a new thread to run it. And when that task terminates, that thread terminates and is never reused again. What you do is just, instead of using one of the cached thread pool executors, you just use the new thread executor with the new virtual thread executor. And that's it. But that's not to say, so it's very easy to learn. You don't need to learn a new API, but you do need to unlearn some habits. Many of the things developers do today when it comes to threads and concurrency are done to avoid, circumvent, work around the high cost of threads. So when you do anything, try to think, is it I'm trying to save resources, save threads, or am I doing it because that's the simplest thing to do? With virtual threads, you don't need to think. Creating a new virtual thread is like creating a new string. You shouldn't worry about it. So the hardest thing perhaps for developers to learn would be to return to the simplest style of coding imaginable. Just forget about the complicated stuff.
What do you think happens to reactive and asynchronous programming?
So reactive, let's split that into two things. Reactive can be a set of practices to make it, and high-level constructs designed to help people write scalable concurrent applications. But people, most of the time, I do too, associate it with reactive streams and the various reactive frameworks. And they, of course, are a style of asynchronous programming. So when it comes to the reactive tradition of various high-level constructs, say circuit breakers, then I guess there is room for higher level libraries on top of Loom. But when it comes to the way they currently work with reactive streams and asynchronous programming in general, I think that the only people who would want to use them are people who actually like them. And I think that the fact is that not many people like them. One of the motivations to invest so much in Loom is that companies came to Oracle and said, like, we don't like this. People use it for good reason. That's the only way, or I don't know if it's the best way today to write code that meets the requirements of the scaling requirements. If you don't use it and you write simple blocking code, you'll just waste hardware and you'll waste money. So people want to write applications that can handle a high load of transactions. So they use these, they have to use them, but they write code that is in stark contrast to how the platform is designed. So their exceptions don't mean anything to them. They can't step through transaction debugger. They have a busy machine that they use JFR to get a profile of, and they see that just a bunch of idle threads because they have operations waiting for I/O, but there is no thread blocked on it. So the profiler doesn't know that anyone is waiting for the I/O, and it doesn't know whether the task that will be spawned after the I/O is done is related to the one that requested it. You lose all context. So most people just don't like it. So I think that kind of programming will be greatly reduced. Only the people who actually like it. No one will have to do it again, but only the people who really like it will continue using it. But the people who make the reactive frameworks today might offer a different style of reactive or high-level concurrency constructs on top of Loom.
Are there any frameworks or libraries that are building in the early access builds of Loom today?
Yes. So first of all, we ourselves tried adapting Jetty. That was very easy to do. Then inside Oracle, we have the Oracle JDBC driver. They made some changes to make it work better with Loom. And the Halidon team made it work well with Loom. And at Red Hat, the JGroups project is also experimenting with Loom. And JUnit. JUnit has a test runner that runs many tests concurrently using Loom as well. That's the ones I remember on top of my head.
Are those publicly available to try?
I think so. And they're respective. Those people made a blog post about them somewhere. So we'll try to find the links.
Yeah, I think these would be good to list definitely in the show notes for this podcast.
Yes, we can do it in the show notes, but I'd rather not publicize, one library, not another, for this podcast, of course.
The question becomes for the listeners and the audience, does this apply to me? I'm not developing a framework. I just have some application that I want to build for my end users, maybe at my enterprise job, maybe at my startup. I may not have a need for Loom, but I have a need for Halidon or Jetty or JDBC. Those things are all very popular. So then the question becomes, maybe we should create a list somewhere where people can see all the different implementations of Loom.
But I would say that if you're not sure whether Loom is for you or not, if you're using thread pools anywhere in your application and you're doing a lot of I/O and you want to handle a high load of requests, then Loom is for you.
Which is probably a lot of people.
Yes.
I did have one question before we move on from the structure concurrency aspect. Have you talked about max concurrency? Because at my previous company, we had a product called Iron Worker. And one of the most popular features was this idea of max concurrency, because we'd spin out a bunch of workers and they'd do some work. But oftentimes those would take down databases or APIs or something. And so we needed a way to rein that in. And so you could queue up, let's say, 10,000 jobs, but you could only have 10 running at a given time. Is there a way in Loom to handle that?
Yeah, so that's a great question. Today, people do something, and I'm often asked about this, and I think it also exemplifies the simplicity of going back to basics. So what people currently do is they say, okay, for accessing the database, say I want no more than 100 concurrent requests from this machine. So they set up a thread pool of 100. And then they have some other microservice where they want, no more than 20 concurrent requests. So they set up a thread pool of 20. And for every stage of their transaction where they want to access one or the other, they take a task and submit it to the thread pool with 20 threads or the thread pool with 50 threads. What you do with Loom is much simpler. And if you go back to the early days when we were thinking naively about writing concurrent code, this is how we would have thought to do it. You just have one thread do that transaction start to finish. It could split if it wants to do multiple things in parallel, of course. It can split and then join. That's the structured part. But when it makes a call to the database, just put a semaphore in front of it. And so if you put a semaphore of 100, then you are guaranteed that no more than 100 transactions will be able to contact the database concurrently. And the other threads will just wait. And that's the exact same thing as would happen if you had the multiple thread pools. And then once they're free, the others will be able to grab the semaphore. Just use semaphores.
You do talk about schedulers quite a bit. And I think one of the big differences of Loom is having the ability to have a pluggable scheduler. Does that apply to, who does that apply to? And at what point would you want a different scheduler from the default one?
Okay, so that is very cool, but we're kind of afraid that this might be an attractive nuisance. In 99% of the cases, I don't think it applies. But it could be very useful in that 1% of cases where nothing else works. Although there are certain use cases where we think it might be more generally applicable. One of them is UI threads. So some people still use Java to write UI applications using either JavaFX or Swing. Those applications have a single thread, the UI thread or the event thread, I think it's called in AWT. And all the operations that change the UI elements must happen on that thread. And whenever they want to do something in the background, like do some I/O, then they have to submit a task somewhere, and when it's done, go back to the UI thread, and it gets complicated. If you were able to write multiple virtual threads that do blocking I/O, but when they actually run, they run on the UI event thread, that could be helpful. So we have people who work on the desktop technologies looking into that. You can try doing it now. It's not immediately going to work because there's a problem of the thread identity. So even though you scheduled, your custom scheduler always schedules you onto the same UI thread, when you ask which thread am I, it will give you the identity of the virtual thread, not of the UI thread. So that requires just changing the assertion in those desktop technologies. But that could be useful. And there are similar cases for people interacting with hardware. I think to use certain GPU drivers, not just for graphics, but for various mathematical processing. Then certain requests can only come on certain OS threads. So in that case, you can use a scheduler that schedules all of your virtual threads onto that particular OS thread. But there are other cases that you may want to consider a different scheduler, but that I would say that is only if for some reason the algorithm used by the default scheduler, which is, so we use fork join pool, it uses work stealing. If you have strong evidence that that's not working for you and it's possible for some workloads, then you can reach for a different kind of scheduler. But other than that, I wouldn't reach for it right away. Just use the default one.
Yeah.
Only if you have a very good reason that you've proven to yourself that that is absolutely necessary should you reach for a custom scheduler.
It's pretty cool though, because to some degree you don't know what you don't know today, and programming models change and use cases change, and that capability could be potentially very important in the future in ways that you may not even know today.
I agree, and I also think it's just cool that something as fundamental as the thread scheduler is written in Java, and you can replace it in code written in Java, and it doesn't even have to implement a new interface. It's just the same familiar executor interface. I think you just have to implement one method, and you've written a thread scheduler.
I bet some people will do it just so they can say they did it.
Oh, I know that they've started already.
So there's a lot of excitement around Project Loom. Can you talk a little bit about what might come next for the project? I don't want to ask you about availability because I know the answer. What are some of the hurdles or what are some of the things that you're trying to accomplish before making it GA?
No, I don't have a date, except to say that it won't be in 16 because 16 is about finished already. The main things we're working on now, functionally, we're mostly done. There is one functional piece missing, one very important feature that's missing, and that is how to do thread dumps. It sounds, just do a thread dump, but if you have 1 million threads rather than a few hundred, there's a question of how to present all the stacks to the user in a way that the user can make sense of. Do we present it tree based on structured concurrency context? Do we try to find identical stack traces and collate them somehow? So that I say is the only missing important feature. But other than that, we still have a bit of work to do in the debugger. It's not quite fully working yet. We still have quite a few stability issues. So Project Loom interacts very, very deeply with the garbage collectors. And it's funny because it hardly interacts with a compiler as a tool, but it interacts with the garbage collectors quite a bit. So we still have some issues of heap corruption with specific GCs onto specific loads and various other crashes that we must fix. After that, we need to do a code cleanup, and then we need to do a port for ARM64. And then we'll be able to consider doing a release. After that, we've already started, so many people probably know already, Loom has a temporary limitation that if you're holding onto a native monitor, namely you're inside a synchronized method or a synchronized block, and you try to do blocking IO, then it's not just that the virtual thread will be suspended, but it will be pinned to the underlying OS thread, and the OS thread will be blocked. You might get other threads to compensate, but it could hurt your throughput. And normally it's not a problem, but if it happens very frequently, then your scalability and throughput will be hurt. But that's a temporary limitation. We've already started working on an alternative implementation of native monitors. It will be done in Java, but it's still very early days, so I doubt it will be part of the first release, but that will be things we want to do later on. And there are other things we're pushing down the line as well.
I'll remind the audience that if you're excited for Project Loom and you're eager to see it in a future release, go and try out the early access builds and provide feedback. Because I presume the more crash reports that we can get or the more real world use cases that we can get reports back, the better you guys will be suited to getting it ready for GA.
Yes, and the faster we'll know when we're ready. So there's always a question, are we ready yet? So feedback is one of the things that helps us to make that determination. Although these days things are a bit easier because we have the preview mechanism. And the preview mechanism allows us to merge something into the JDK project without committing to it forever. So it gives us a bit of a leeway to say, well, 95% done, and let's go ahead and do it because there's still time to fix it later.
Right. Well, I have a couple last questions. Do you have an idea of the future of programming and what that might look like?
The future of programming. The first question, who's the programmer? I don't think that the systems programming is going to change much in the coming decades, but when we come to application programming and high-level application programming, like doing a simple CRUD application, there was one attempt that I thought was very interesting. Unfortunately, they ran out of money. The language was called Eve. Of all the other attempts, I think that one came closest to doing something different and interesting. Although, going back to the 90s, every 10 years or so, people come up with these other RAN technologies like this is going to be the future of programming, and it never is. So I wouldn't know, but if you told me you must bet on one approach that is not, things aren't going to change, then the one that I like best for application programming is Eve.
All right, so since this is the Inside Java podcast, give us an idea of what a typical day for Ron Pressler looks like.
I don't know if there is a typical day, but there are various things I do. So first of all, I'm one of the people actually writing code. And depending on the day, much of my time is spent writing code. These days, that part is mostly fixing horrible bugs that have to do with interaction with the garbage collector, which is very hard to... These are very tricky bugs. And also some technical problem which people might sympathize and empathize with is merges, especially the VM. So the OpenJDK VM is called Hotspot, and it's changing very rapidly. And every week or so, we try to... So Project Loom is developed in a separate repository, and every week or so, we do a merge with all the changes that went into mainline. And the last few weeks meant that there were some pretty hairy merges. It's usually Alan Bateman that does them. This time I did them, and that took up a lot of my time. So when I'm not programming, I could be writing talks and presenting. Mm-hmm. And every week we have a project update meeting. So the people who work in the project, so they're all Oracle employees except for Andrew Haley, who's a Red Hat employee. But anyone who says, I want to join the project, and they commit to working a certain amount of time on it, commit coming to the meetings. So it's open to everyone. So in this case, it's Oracle and one member of Red Hat. Mm-hmm. And in that meeting, that usually runs for an hour and a half, each of us says what they've done the past week, what they want to do the week after. In addition to that, we could have various design meetings for different areas, like what to do in the debugger, etc. Almost everyone is a very experienced developer. I don't think we have anyone with... No, we have maybe one person with less than 20 years experience, but I don't think we have anyone with less than 10. So it's a very experienced team. It's just a matter of making sure that we're moving forward and we all understand the direction we're going. There is no management involved or anything like that. And most of the people, because I'm a latecomer, most of them know more about OpenJDK than me. Once every 2 weeks, Alan Bateman and I meet with Doug Lee, who does most of the Java util concurrent work, or all of it, and he wants to add channels. The only problem is that the name channels is already taken by NIO, so he is considering different names. I think his first choice was Carrier. His current choice is Conduit. So now they're called Conduits. Maybe they'll have another name later on. So meeting with people, programming, and writing. That's most of it. Right. Responding to emails and spending time on Reddit, which is a bad addiction, personal addiction of mine.
Well, our Reddit community definitely thanks you. Ron, thanks for taking the time on a Friday afternoon to be on the Inside Java podcast.
Thanks, Chad.
Shiv, thanks for being the first cat on the show.